Live. Okay, so 11, 21, 19. So the objective today, what we're talking about is geometric sequences, yeah, and series. Okay, so if it's geometric, then what we're doing is multiplying or dividing, right? Multiplying or dividing each term by the same number, okay? And if it is geometric, so if I take a look at example 1, of course I'm getting a little heady right now, okay, I don't want to get too far ahead, but if it is geometric, we're multiplying by the same number each time. If I take a look at example 1, looks like it's times by 3, times by 3, times by 3. So now if you're not sure, it's so easy. If you can't figure out what the multiplier is, R, easiest way to find R is simply the second term divided by the first term. That will always give you the multiplier, right? And that makes sense. In order to make the next term, you multiply. So to back it up and do the opposite, just divide, right? So if I divide 15 by 5, it's obviously in this case 3. So my multiplier, my ratio is 3. But if you can't see it, but I see times by 3, times by 3, times by 3. Everybody agree? Times by 3? So that's my multiplier, or it's called my ratio. Okay, so my ratio is 3. And if I want to find the 20th term, I'm just going to use my formula. So I'm going to use my A of n formula. And since I'm looking for the 20th term, I'm going to write it as A of 20, because I'm looking for the 20th term, right? Equals A1, which is 5, times R, which is my ratio, or my multiplier, which is 3. I want the 20th term, so n is 20. So go 20 minus 1. Now, just need my calculator. Do not make that 15, please. You know better than that. That would bother your Aunt Sally desperately. She would not like it if you multiply those, because it doesn't follow the order of operations. Please excuse my dear Aunt Sally. Did you guys ever learn it that way?
Yeah.
Oh, are you talking about
Order of operations. Order of operations, yes.
How do you know that?
To the power of 20 subtract 1. Now, I probably would have shortcutted that to 19, but it's okay. There it is, right? Guys, ever see it in the calculator?
It's a really long number.
It is a big number, because when you are multiplying, these grow exponentially. Remember we talked about exponential growth? These are exponential growth because you're multiplying by 3 each time, so it is. Let's see, I got to write all these numbers down. I'll put some commas in a second. 5, 8, 1, 1, 3, 0, 7, 3, 3, 5, comma, comma, comma. Okay, thousands, millions, billions, so it's 5,811,307,335. Pretty big, huh? Yeah. They get big fast because these really are exponential growth. Okay. All right. Example 2. So write a rule. What I don't know is R. And I really don't even know the first term. Right? But let's just set it up. I know it's geometric, so I'm going to use my formula, which is A of n equals A1 times R to the n minus 1 power, right? So what I'm going to do is find A1 first, okay? Or maybe I can find R. Let's move everything back. Let's shift everything back. Let's make this one A1 for a second. So I shifted that back 2. So let's make this one A4 for just a minute, okay? And then, regardless of where this darn pattern is, the pattern stays the same, right? You're still going to be multiplying by something, multiplying by something, multiplying by something, right? So the pattern never changes. We're just going to shift this over, okay? All right, now, A1. So let's use our formula. So I'm going to go 1,458, which now is my fourth term, right? Equals my first term, which is 54, because I shifted and made that my first term, times R. Now I need to find R, but when I shifted this term to 1,458, I made it the fourth term, right? So N is 4 in this case, so I get a 4 minus 1. So now N is 4. Okay, now I got to solve. All right, let me simplify a little bit. Okay, let me simplify a little bit. 1,458 equals 54 times R to the third power, right? You guys good on that, right? I got to solve for R. Divide, right? Isaac, you lost for a second.
Oh no.
You sure?
Yeah.
Okay. Divide by 54. Everybody agree with that? Divide by 54. Seems like the most obvious step. Okay, 1,458 divided by 4.
27.
54. Okay, 27. Thank you. 27 equals R to the third. And then what do you guys think we're going to do next?
Cube it.
Cube root it. Well said, Isaac. You guys agree with cube root? Right, so if I cube root, what's R going to be?
3.
3. Because we know the cube root of 27 is 3, because 3 times 3 times 3 is 27, so R is 3. So now I know the multiplier, right? So if I know the multiplier, I can go, okay, I'm going to go, all right, here's my formula so far. I'm going to go, all right, I'm going to go A of N equals A1 times 3 to the N minus 1 power, okay? Now I don't know the first term, but probably the easiest way to make the first term is just to run it backwards. Run it backwards. What do I mean by run it backwards? Well, a little bit of side work over here. I know this. A3, A2, A1. I know 54 is third term, right? I know 54 is third term. So what I did is I multiplied by 3 to get 54. So let's work it backwards. What are we going to do?
It's 18 and 6.
How'd you get that so fast? You
Divided by
divided by 3. Does that make sense? You multiply by 3 to get here. We're just going to divide by 3 to work it backwards. Nice job, Lily. Aren't you guys glad Lily's here? I am. Lily's awake today. So, Lily, divide by 3. What'd you get? 18? Divide by 3 again, and you got 6. So my first term has got to be 6. Okay, so now I can finally make my formula. I'm going to go A of N equals 6 times 3 to the N minus 1 power. Thanks, Lily. Okay. So we just had to work things around and get the answer, but we can do that. Okay. Thumbs up. Okay, I see 2 thumbs up. 3. I knew that I had a third one there. Okay. Isaac, give me thumbs up when you're ready. Okay, I'm not going to turn it until you got it, okay? All right, flip the page. Everybody good? Okay, let's take a look at number 3. Okay, so number 3, I see the pluses, right? See the plus, 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 plus. So number 3 is a series. Number 3 is a series because anytime we multiply, it's a series, right? And if it is geometric, we have a formula. Now, is this one geometric? I think so. What do you think's going on? Times by 3, times by 3, times by 3. So this one is definitely geometric. It is geometric. Because I know my multiplier or my ratio is 3. Pretty good on that. I know my first term is 2, right? And so if I want to find the sum, I'm going to use my formula. So if I want the sum of the first 20 terms, then I know n has to be 20, okay? I want the first 20 terms, n is 20. So let's plug things in to my formula. So we're going to go S of 20, because I'm looking for the sum of the first 20, is equal to A1, that's my first term, is 2. 1 minus my multiplier, which is 3, to the 20th power, parentheses. Make sure you get your parentheses in the right spot. Divided by 1 minus 3. Okay, now suppose if you want to change your formula, you can, huh? Sure, why not, right? Okay, so then I'm just going to use my calculator. I'm going to make sure I put the parentheses exactly where they belong, right? 2, parentheses, 1, subtract 3 to the 10th power, right?
20th.
20.
Nope, sorry, my bad. Thank you. 20th power. Thank you, Lily. I'm going to make some mistakes today, huh?
We both said it.
Yep, minus 3. Okay, right? Does that look right? Boom. Whew, big number, huh? Okay, let's write that down. Big number. I got 3, 4, 8, 6, 7, 8, 4, 4, 0, 0, comma, comma, comma. Let's see, that's got to be 3,486,000,000.
May I ask where we need this?
Absolutely. Okay. Right. It's a really easy example, okay? Super easy example. You are working in a manufacturing plant, okay?
Now.
And let's just say you're making water bottles, right? And you keep bringing in people to help you with your production. So like every hour, maybe we double our workforce because people just keep coming in to help us out, right? It's a volunteer thing, right? So at one point, Isaac, I'm saying, dude, we're going to run out of room in our warehouse. And you're going to say, no, we're not. I go, no, Isaac, if I do the math, our warehouse can only hold this many water bottles. Like, let's say only 1 million water bottles. I want to say, but Isaac's going to say, no, we're not going to have 1 million water bottles. Like, no, Isaac, are you kidding? After so many hours, we're going to have 3 billion water bottles. So that's just a simple example in manufacturing where if you're making something at a big rate, you got to know how many you're going to make, right? Yeah. Was that 2? Yeah, they did in this case. All right, so last but not least, number 4, okay? Before I even start, what does this symbol mean? It means sum, right? So that means I'm going to use the same formula, right? Now, is it geometric? Is it geometric? If you look at it, it looks identical to our formula, doesn't it? See this formula here? Look at this formula. I want everybody look here, okay? That's our geometric formula. Does our question look like that?
Yes.
Yeah, it does. But if you want to, you can make several terms, because I'm going to show that too, just to verify. Okay, Jay, you got to go? Okay. So if I want to make the first term just on the side, A1 is going to be, all right, negative 3. A2 is negative 4.5. A3 is, multiply that times 1.5. Negative 4.5 times 1.5 is a negative 6.75. And you really are multiplying each time. It really is geometric, okay? So if it is geometric, let's use our formula. It's pretty easy. So it is S of n equals A1 minus R to the n power all over 1 minus R, okay? So, A1, what's our first term? Lily just told you, right? Our first term is negative 3. What's our multiplier?
1.5.
It is 1.5. It's right in the formula, right? You guys agree that's my multiplier? See, this question fits this formula perfectly, doesn't it? That's my multiplier, 1.5. There's my first term, 3. Okay, so it's pretty slick. So let's go straight to S of 15. Why did I put 15 there?
Because you're trying to get all 15.
Yeah, because 15, I'm going to plug in 1 through 15, so it'll be 15 numbers. Again, I'll say it again. I'm going to plug in 1 through 15, so there'll be 15 numbers. Okay, so then A1, negative 3. 1 minus my multiplier, which is going to be my 1.5 to the 15th power, parentheses, divided by parentheses 1 minus 1.5, okay? So the parentheses, you have to have the parentheses, otherwise your calculator will give you a totally different answer. So, putting it in my calculator carefully, negative 3, parentheses 1, subtract 1.5 to the power of 15, okay, parentheses divide parentheses 1, subtract 1.5, parentheses, and I get a grand answer about negative 2,621 oh, how about 36, okay? There's a few more decimals, but that's all I need, okay? All right, what do you guys think? Not that bad? Okay, now, the cool part is this.